In this lesson, we're going to go over some tips on how to solve quantity rate problems. These are also known as quantity value problems or mixture problems. The difference between a quantity and a rate is that a quantity is going to tell us how much of something that we have. How many number of gallons, number of dollars, number of pounds. If we're able to count the item, that's going to be a quantity. A rate or a value is going to be the measurement of that item. So that could be miles per gallon, concentration of a liquid, the type of currency, whether it's a nickel or a dime. That's the value or the rate of that item. Our strategy for solving these problems are, of course, to read the problem very carefully and to underline the facts. That helps. Then we're going to create a table because these problems have a lot of information in them. It really helps to create a table in order to, because these problems have a lot of information in them, it's easy for us to create a table in order to organize all that information. What also helps about the table, it helps us actually write the equation because we're going to set up this table in a very specific way. Once we have the equation, the rest is easy. We solve the equation and then we relate our answer back to the original problem. So let's start off with this example. 200 tickets were sold for a baseball game, which amounted to $840. Student tickets cost $3 and adult tickets cost $5. Find the number of each type of ticket sold. The very first thing that you're going to want to do is first list out your items and then put in units for our quantity and our rate. So notice how we have a quantity. Notice how we have a column for the item, a column for the quantity, a column for the rate, and then our last column is the quantity times the rate. So once we fill out all the information, in the first two rows, we're going to multiply the quantities times the rates. So I have student tickets as an item, adult tickets, and then I have the combination because if you read this, we know 200 total tickets were sold. So my last row many times is known as your totals row. I also put in my units. So for quantity, I have the number of tickets. For rate, it's the price per ticket. Now we have all the information we need in order to build our table. 200 tickets were sold, and that amounted to $840. So if I go to my totals row here, my student and adult tickets, the number of tickets was 200. There's no rate for student and adult tickets, so I don't have anything in here. So that's okay. You could either put an X or you could leave it blank. There's no information for that box. But I know that the total amount of the quantity of student and adult tickets is $840. So this row is kind of like the total cost or total price. We know that student tickets cost $3, so it's $3 per ticket for student tickets. Adult tickets are $5 per ticket. And I need to find the number of each type of ticket sold. So this is all the information that the problem gives us. It's quite a bit of information. We now need to put in something for the quantity for my student tickets and my adult tickets. I have no idea how many student tickets I have, so I'm going to call this X. My adult tickets, if I sold 200 total tickets and X of those tickets go to the students, then the adults get 200 minus X. Because if you add the student tickets with the adult tickets, you should have 200 total tickets. Now that I've filled out my quantity and my rate in my first two rows, I'm going to multiply across because I know the number of tickets times the price per ticket is going to give me the total price of that particular type of ticket. if you go back to our strategy, we defined our variable, we wrote a second quantity. Now we're going to write an equation based on the last column. That's where this table really helps us. This quantity times rate column actually gives us our equation. We know the number of student tickets plus the number of adult tickets times their price should give me $840 because that's how much all 200 tickets brought in. I can now solve this equation. So I start by distributing that 5, combining like terms, and I can subtract that 1,000. So x is equal to 80. So that means that there are 80 student tickets. So that means there's 120 adult tickets. Let's try another one. Florence works 36 hours one week at $7.50 per hour. She's offered overtime at $11 per hour. Find out how many hours she must work overtime to average $8 per hour. So again, I start by filling in my items and my units. So we have our regular time, we have her overtime, and then we have the combination. That's her paycheck. It's going to be a combination of regular time and overtime. Our quantity, what we're counting here, are the number of hours that she works. And our rate is how much she makes per hour. So this last column, this quantity times rate, is going to be her total paycheck. So the number of hours of regular time is 36, and she gets $7.50 per hour for it. She's offered overtime at $11 per hour. Okay, we need to find out how many hours of overtime she must work. So we don't know how many hours she worked, but we do know that she wants to average $8 per hour. So that means the total quantity of hours she's working is 36 regular plus those unknown overtime hours. Now that I have my boxes filled out, I could go ahead and multiply across. 36 times $7.50 is $270. X times 11 is 11x. And we have 8 times 36 plus x. I can now write an equation that is going to represent her total pay. 270 plus 11x, so it's always the first two rows added together are going to equal the last row. Think about it logically. Her regular time plus her overtime is going to give us the final amount that she makes. And I could solve this equation now. So I have 270 plus 11x is equal to 288 plus 8x. I'm going to subtract the 8 over to the left-hand side and subtract the 270 over to the right-hand side. So I get 3x is equal to 18. Divide by 3, x is equal to 6. So she needs to work 6 hours of overtime in order to average those $8 per hour. In our last example, we have what is known as a classic mixture problem. How many gallons of a 60% solution must be added to 30 gallons of a 10% solution in order to produce a 20% solution? So I have 3 items. I have the 60% solution, I have the 10% solution, and I have the 20% solution. My quantity is the number of gallons, so how many gallons are being added. My concentration is going to be my rate. It's the percentage of the solution. Now, they don't tell us what type of solution. It could be an antifreeze solution. It could be a salt solution. So we're looking for how many gallons of the 60% solution. So that's my X. And the concentration, when we have percents, is we always want to write it as a decimal. My 10% solution, we know we have 30 gallons of it. We want to produce a 20% solution. Well, if I add X gallons to the 30 gallons that I already have, X plus 30 is how much of the 20% solution I'm going to have. The concentration is 0.2. All of these boxes are filled out, so I can multiply across. So my equation is 0.6x plus 3 is equal to 0.2 times x plus 30. 0.6x plus 3 is equal to 0.2x plus 6. 0.4x is equal to 3, so x is equal to 7.5. So 7.5 gallons of the 60% solution. So to review the steps, the first thing we want to do is fill in our items that we're looking for. Be as specific as possible because that's what helps you fill out the table. Then you're going to fill out the units of your quantity and your rate. After that, it's all about putting the information in the box. So you want to read the problem very carefully, and then before you go to fill your equation, just double check that you put the information in correctly. Once you have the information in, we multiply across, and we have our equation from that last column. We solve that equation and relate our solution back to the original question.